Hello again. In the next few videos, I'll be talking about the matrix. As before, I'll take you through all the basics you need to know about this new data structure. So, what's a matrix? Well, a matrix is kind of like the big brother of the vector. Where a vector is a sequence of data elements, which is one-dimensional, a matrix is a similar collection of data elements, but this time arranged into a fixed number of rows and columns. Since you're only working with rows and columns, a matrix is called two-dimensional. As with the vector, the matrix can contain only one atomic vector type. This means that you can't have logicals and numerics in a matrix, for example. There's really not much more theory about matrices than this. It's really a natural extension of the vector going from 1 to 2 dimensions. Of course, this has its implications for manipulating and subsetting matrices, but let's start with simply creating and naming them. To build a matrix, you use the matrix function. Most importantly, it needs a vector containing the values you want to place in a matrix and at least one matrix dimension. You can choose to specify the number of rows or the number of columns. Have a look at this example that creates a 2 by 3 matrix containing the values 1 to 6 by specifying the vector and setting the n row argument to 2. R sees that the input vector has length 6 and that there have to be 2 rows. It then infers that you'll probably want 3 columns, such that the number of matrix elements matches the number of input vector elements. You could just as well specify n_col instead of n_row. In this case, R infers the number of rows automatically. In both these examples, R takes the vector containing the values 1 to 6 and fills it up, column by column. If you prefer to fill up the matrix in a row-wise fashion, such that the 1, 2 and 3 are in the first row, you can set the by row argument of matrix to true. Can you spot the difference? Remember how R did recycling when you were subsetting vectors using logical vectors? The same thing happens when you pass the matrix function to a vector that is too short to fill up the entire matrix. Suppose you pass a vector containing the values 1 to 3 to the matrix function and explicitly say you want a matrix with 2 rows and 3 columns. R fills up the matrix column by column and simply repeats the vector. If you try to fill up the matrix with a vector whose multiple does not nicely fit in a matrix, for example when you want to put a 4-element vector in a 6-element matrix, R generates a warning message. Actually, apart from the matrix function, there's yet another easy way to create matrices that is more intuitive in some cases. You can paste vectors together using the cbind and the rbind functions. Have a look at these calls. Cbind, short for column bind, takes the vectors you pass it and sticks them together as if they were columns of a matrix. The rbind function, short for row bind, does the same thing but takes the input as rows and makes a matrix out of them. These functions can come in pretty handy, because they're often more easy to use than the matrix function. The bind functions I just introduced can also handle matrices actually, so you can easily use them to paste another row or another column to an already existing matrix. Suppose you have a matrix M, containing the elements 1 to 6. If you want to add another row to it, containing the values 7, 8 and 9, you could simply run this command. You can do a similar thing with cbind. Next up is naming the matrix. In the case of vectors, you simply use the names function. But in the case of matrices, you could assign names to both columns and rows. That's why R came up with the row names and column names functions. Their use is pretty straightforward. Retaking the matrix M from before, we can set the row names just the same way as we named vectors, but this time with the row names function. Printing M showed that it worked. Setting the column names with a vector of length 3 gives us a fully named matrix. Just as with vectors, there are also one-liner ways of naming matrices while you're building them. You use the dimnames argument of the matrix function for this. Check this out. You need to specify a list which has a vector of row names as the first element and a vector of column names as the second element. Don't panic if you've never seen this list function before. You'll learn all about that later on. As I explained in the beginning of this video, matrices are just an extension of vectors. This means that they can only contain a single atomic vector type. If you try to store different types in a matrix, coercion automatically takes place. Have a look at these two matrices, one containing numerics, the other one containing characters. Let's now try to bind these two matrices together in a column-wise fashion using cbind. Did you see what happened? The numeric matrix elements were coerced to characters to end up with a matrix that is only comprised of characters. To have a multidimensional data structure that can contain different elements, you'll have to use lists, or more specifically, data frames. Up to you now to become a Jedi in the world of matrices. Enjoy it, you shall.